Welcome to Safety Engineering Briefings. Short, practical insights for software and security engineers. Last month, a major online retailer experienced a significant outage. Not a DDoS, not a database failure. A simple, overlooked edge case in their promotional pricing engine. Millions in lost revenue. The root cause? The team building that engine was certain their testing covered everything. They weren't wrong, within their defined scope. But their scope was too narrow. It's a common trap. We feel confident. We assume we've thought of everything. That's where things break down. Overconfidence isn't about arrogance. It's about incomplete mental models. We build systems. We test them. We see success. That reinforces our model of how the system should work. But reality is messy. We tend to focus on the happy path, the expected inputs, the common scenarios. We optimize for what we know. We neglect the corners, the unusual combinations, the things we deem impossible. This happens because testing is hard. Thorough testing is exponentially harder. Every input, every state, every interaction adds complexity. Teams often make implicit assumptions to reduce that complexity. This input will always be validated upstream. This condition will never occur in production. The user won't do that. These assumptions become invisible. They're not documented. They're not actively tested. They're just not understood. Another factor is the illusion of control. We write code. We deploy it. We monitor metrics. If the metrics look good, we assume the system is good. But metrics are lagging indicators. They tell you what happened, not what could happen. They don't reveal the hidden vulnerabilities, the untested edge cases, the subtle interactions that can lead to unexpected behavior. Finally, there's the pressure to deliver. Tight deadlines, feature requests, constant change. These pressures incentivize shortcuts. They encourage us to prioritize speed over thoroughness. We skip tests. We defer refactoring. We accept technical debt, and that debt accumulates, increasing the risk of overconfidence and eventual failure. Let's consider a simplified e-commerce order processing system. It handles payments, inventory updates, and shipping notifications. The team is confident in their unit and integration tests. They've covered the standard scenarios: successful payments, sufficient stock, valid addresses. But what happens when a customer places a large order, just as a scheduled inventory update is running? The system might briefly show negative stock levels. The payment processor might authorize the charge before the inventory is fully updated. The order gets placed, but the warehouse can't fulfill it. This isn't a flaw in the code itself. It's a race condition, a timing issue. The team didn't explicitly test this scenario because they assumed the inventory update would always complete before the order was processed. They didn't consider the possibility of concurrent access. The consequence? Angry customers, refund requests, reputational damage, and a frantic scramble to fix the problem. A simple locking mechanism or a more robust transaction management strategy could have prevented it, but it required anticipating a scenario the team deemed unlikely. Overconfidence stems from incomplete understanding, not malice. It's a natural human tendency, but in software, it's a critical vulnerability. Actively seek out the assumptions in your system. Question everything. Prioritize testing edge cases. Remember that metrics are not guarantees. If this topic was useful, take a moment to reflect on how it applies to your own systems. See you in the next briefing.